Hello everyone, and welcome to this new tutorial where we'll learn how to create a 3D mechanical design using SolidWorks 2018. In today's video, we'll walk through the step-by-step process of designing and assembling a practical mechanical project often used in conveyor systems, the belt roller support. As shown in the technical drawing in front of you, the project consists of several precise mechanical components, including the base, the brackets, the roller, the shaft, and the internal bushings. We'll learn how to model each part individually using essential SolidWorks tools, and then move on to assemble them in an assembly document, while strictly following all the dimensions and specifications provided in the drawing. Whether you're a beginner or someone with basic experience, don't worry. We're starting from scratch, and I'll explain every feature and command I use clearly with live demonstrations inside the software. So let's begin with the first step in designing this exciting engineering project. Once we launch SolidWorks, we begin by selecting New SolidWorks Document, then choosing Part, which allows us to create a 3D model of a single component. We'll start with the first part, the base. We switch to the Sketch environment and select the Line tool from the Sketch tab. This tool is used to draw straight lines, forming the boundaries of the part, for example, the outline of the base. After drawing the base sketch using the Line tool, you'll notice the lines appear blue with green relation symbols, like horizontal, vertical, or coincident. Now we use the Smart Dimension tool to define the exact measurements. You can also add or modify points, or use the Fix option to lock specific geometry in place. In SolidWorks, defining dimensions with Smart Dimension is a key step to ensuring precision and stability in your design. This tool helps you define lengths, angles, distances, and geometric relations accurately between sketch entities. Once fully constrained, the sketch turns black and appears shaded in gray, which indicates it's fully defined and closed, ready for 3D modeling. We move to the Features tab and choose Boss Extrude. In the Direction 1 option, I selected Mid-Plane. This ensures the extrusion grows equally in both directions from the sketch's center, maintaining symmetry in the design. I set the depth to 56 millimeters, which defines the thickness of the base. Click the green check mark to confirm and create the solid 3D body.
Next, we select the top face of the base and start a new sketch on it. We use the Circle tool to draw two circles, one near the top left corner and another near the bottom left corner. We then define the positions and diameters of the circles precisely using the Smart Dimension tool, aligning them relative to the base's edges. Now that both circles are in place, I use the Linear Sketch Pattern tool to duplicate them across the horizontal, the x-axis. First, I select the two circles, then leave Direction 1 set along the x-axis with number of instances equal to 2 and spacing equal to 108 millimeters. SolidWorks automatically generates two more yellow previews, one for each original circle, so we now have 4 evenly spaced circles. After confirming with the green checkmark, I add one final dimension of 108 millimeters between them, then proceed to use the Extruded Cut feature to drill through the body. I set the cut direction to Through All and confirm, and just like that, we have cleanly cut holes. Now it's time to save the part to your computer.
Next, we move on to designing the roller. We create a new part, open a sketch, and select Insert Line. I begin sketching the profile using the centerline tool to define the central axis of the roller. Then use the line tool to draw half of the roller's profile above the centerline. If I make a mistake, I use the Trim Entities tool. From the side toolbar, I choose Trim to Closest, then click on the unwanted segment to remove it. Simple and direct. After correcting the shape and ensuring all endpoints are connected, I define exact values using Smart Dimension, like setting the top width to 30 millimeters, then continue setting other dimensions. Now, I move to the Features tab, select Revolved Boss Base, and choose the center line as the axis of revolution. Since I want a full rotation, I leave the angle at 360 degrees, then confirm. The roller is now complete. Don't forget to save the part to your computer.
Once again, create a new part, go to Sketch, select Front Plane, and use the Line tool to draw the shaft's profile, just like we did with the roller. Once finished, remember to save the part. And that's it for today's part. We've successfully modeled the base, the roller, and the shaft of the belt roller support. In the next part, we'll continue designing the remaining components, including the brackets and the bushings, and then move on to the full assembly of the project inside SolidWorks. You'll find the link to Part 2 in the description box below or pinned in the top comment. If you found this tutorial helpful, don't forget to like the video, comment your questions or thoughts, subscribe to the channel for more tutorials, and feel free to share it with your fellow engineering students or CAD lovers. Thanks for watching, and see you in the next part.